Shruti. Shruti, what is your roll number? Who is this Shruti? Shruti, what is your roll number? Someone has joined on the name of Shruti. So who has joined by the name of Shruti? If you have changed your name means you just let me know. I will mark the attendance. Otherwise you will be absent only. श्रुति का नाम पर कौन ज्वाइन हुआ था? रोल नंबर 20.
यस सर।
कौन सा नाम पर ज्वाइन हुआ था?
मैं विनायक नाम पर ज्वाइन हुआ।
ठीक है, someone has joined on the other name. Nothing to worry. I don't know who is that. So how many experiments are over? Anyone, can you tell me?
4.
4 experiments are over. 4 or 5?
तर ते अनबॅलन्स आणि अनबॅलन्स वेगवेगळं लिहायचंय का?
Those are separate. Separately, I told you to separately we have to do that one.
Okay.
So total 5 experiments are over already. So today we are going to discuss about the 6th one. Before starting the 6th one, just a minute. I'll check which day we have there. Number 35, the strength is not today. So screen is visible?
Yes sir.
Okay. So the experiment number 6 we are going to discuss, that is called measurement of inductance by using Maxwell bridge. In the previous laboratory, we have discussed about the measurement of resistance by using Whitson bridge, and by Kelvin double bridge also we can measure the resistance. The basic circuit elements are resistance, inductance, and capacitance. So resistance part we have finished. Now we will go for the inductance part, and after this we will go for the capacitance part. So the title of experiment number 6 is measurement of inductance by using Maxwell bridge here. So the aim of this experiment is to, the main aim of experiment is to measure the unknown inductance by using Maxwell bridge. We have to use the Maxwell bridge. So these are the components we have to do. If we are going physically in the laboratory, we have to do means the Maxwell bridge kit is required. Digital storage oscilloscope is required for the measurement of the voltage and all the things, and unknown inductance. We can vary the inductance kit. Unknown inductance is required. Digital multimeter is required to measure the voltage. Connecting patch cards or connecting wires, we are going to call that one. Connecting wires are required here now. So this is the aim and apparatus here now. The circuit diagram actually from the virtual lab, we are going to use this one. So it is a Maxwell inductance and capacitance bridge. Actually, Maxwell bridges are classified into two types. The Maxwell bridges are classified into two types again. So this bridge we are going to use or utilize for the measurement of inductance only, but in a combination of capacitor also we are going to use. We are going to use with capacitance also here now. For that reason, only the circuit consists of resistance and inductance. That bridge is called Maxwell inductance bridge. If the circuit consists of all the components, resistance, inductance, capacitance, so that bridge name we have named as Maxwell inductance capacitance bridge here now. That one is named as Maxwell inductance capacitance bridge here now. Already the resistance is a real part, so it will be there in all the circuits over there. We can consider that. So extra thing, we are adding some inductance, we are adding in the bridge. So Maxwell inductance bridge, we are adding inductance and capacitance in the circuit, means that is called Maxwell inductance capacitance bridge. Yeah, telling here now. So one by one we will discuss here now. So this is the Maxwell inductance bridge here. Only R1, L1, here R2. This L2 is there, but it is not a pure inductance. It has some resistive part that is called small R2 here considering here now. क्या बोल रहे? Yes, somebody has told something. Okay. So the first arm, that is first branch, it has resistance and inductance is there. That is pure resistance and inductance, not that is non-resistive inductance. It has this one we are going to call it as unknown resistance, unknown inductance we have to identify. And here R2, that is variable resistance we are going to use to make the bridge into balanced condition. So R2 we have used here now. The L2 is also we are variable we are using. This is not pure non-resistive, it is resistive inductance is there. It has some resistance of R2 here now. And R3, R4 we are using here now. So 4 branches are there here now. That A to B, B to C, C to D, and D to A here now. So that across A and C the supply is given, AC supply is given, and in between B and D we have connected a detector we have connected here now. This phasor diagram and all the things I will explain in the third unit part. Theory part I will explain here. So this one, the detector, whenever the bridge is unbalanced, the detector will act as a here, it will connect a path here now. So some current will flow here now. If the bridge is balanced condition, no current will flow here. So voltage drop across A to B equal to B to C, then no current will flow. This bridge is act as a open circuit here now. This path is act as open circuit. Current flowing through this one will be 0 here. And the potential difference between A to D or D to C, that is also equal. Then also the bridge is act as 0 only. So the A to C equal to A to C here now. ABC equal to ADC. Then the bridge is balanced condition, we can say here. So we already know the formula for the Maxwell, which is that one, Whitson bridge. We know the formula, that is R1, R4 equal to, we know or not? R1, R4 equal to R2, R3. This is the basic equation for all the bridges under balanced condition. This one we are using for the Whitson bridge here now. This Maxwell bridge is the advanced form of Whitson bridge, but The Wilson bridge has only resistances over there, but it has resistances as well as inductances are there here now. Resistance and inductance both are there here now. So we can say that one instead of R, the combination of resistance and inductance, what we will call that one? What did it mean? Z means what? Electrical student, diploma electrical students. Have you heard the parameter? R means what? Resistance.
Yes, sir.
L means what? Inductance. C means capacitance. So RLC, have you heard the name RLC circuit? कोई तो reply दे दो.
Yes, sir.
RLC. Suppose, what do you mean by this XL? Have you heard this name XL, XC? सिर्फ yes बोलने के लिए है क्या तुम लोग? वो तो बोलो. I am asking, have you heard the name of XL and XC? You have finished your diploma, then also it is very hot. Situation is very critical here. Viraj Seti, Nilesh Babers, Kale Satyam, Satyam Kale, are you there? Seti Viraj.
Yes, sir.
Have you heard the name of XL, XC? Sonali? Sonali Chavan.
Yes, sir. Maxwell induction bridge.
Maxwell inductance. Very critical condition is there. You have to learn from basic electrical engineering subject first. Then see here, this R is resistance, inductance, capacitance. Actually, the X is, it is called as a reactance. We are going to call this one here. This is called reactance. XL is X is L is inductance, means inductive reactance. XC is capacitive reactance. This much basic I am telling to you peoples only. Last 2-3 batch I have handling the subject. For you peoples only, this much deep I am going. I don't know you why you peoples are not understanding. So X is reactance here. No, XL is inductive reactance. XC is capacitive reactance. Actually, I don't know how many of you know this one. XL equal to omega L, we are going to call that one. Omega equal to, वो तो बोल दो at least. Omega equal to
Angular velocity.
Angular velocity. The formula for omega is 2 phi f. Yes, omega equal to 2 phi f. The L as it is here. No, that is called inductive reactance. That is called omega L. XL equal to omega L. But the capacitive reactance 1 by omega C will come here now. For the XC equal to 1 by omega C here now. 1 by omega C or equal to 1 by 2 phi FC. That one also we can write here now. So if it has, we are the unit of reactance is also ohm only we are going to use here now. So if the circuit, it has both combination of resistance, capacitance, inductance, that is called, we are going to call as impedance circuit. That is called Z, we are going to call here. If only resistance is there, the circuit in a AC circuit, that is Z equal to R. If the combination of resistance and inductance is there, then we are going to call as, in the complex form we can write R plus or minus JX here now. Plus or minus JX. If resistance of inductance, capacitance, and if the circuit consists of resistance, inductance, capacitance here. This X is reactance here now. Net reactance we are going to call. It may be XL, it may be XC, or it may be XL minus XC, or it may be XC minus XL here. It may be here. Is it clear? That is called inductance we are going to call. For the DC circuit, only resistance is there. We can use R1, R4, R equal to R2, R3. But for the AC circuit, here it is a combination of resistance and inductance is there. So this R1, R4, R equal to R2, R3, I will write in the form of Z1, Z4 equal to Z1, Z4 equal to what you can write? This
Z2, Z3.
Z1, Z4 equal to Z2, Z3 here now. We can write this like this here now. Z2, Z4 here. See, from this circuit, it is a combination of resistance and inductance here now. So this is called, I will consider as Z1 here. This one is Z1 and this one is, what is this one? R2, L2, this is called Z2 and this one is Z3 and this one is Z4. Can anyone tell the formula of Z1? Z1 equal to what? We can write this one. Here, Z1 is already there. Z1 is already there here now. So, can I write Z1 equal to R1 plus JXL? JXL1. JXL1 here now. Can I write like this? Yes or no? R1 plus JXL1 here now. Z2 equal to R2. This resistance is the variable that is called R2. I will use here now. R2 plus. Is there any other resistance also here? One more R2 is there here. That is also real term. That is called R2 plus R2. Plus the inductance is there. That is called plus JXL2. We have to use here. JXL2. So Z3 equal to anyone, can you tell? Z3 equal to? Is there any reactive part over there? Inductive part is there here? Inductive part hai ya? No. So then Z3 equal to R3 and Z4 equal to R4. Directly we can write here. Z3 equal to R3 and Z4 equal to R4 here. Substituting these all equation here in this one, Z1 we have to substitute R1 plus JXL1 here now. Z2 you have to substitute this R1, R2 plus JX2 here now. And Z4 we have to substitute R4 and Z3 we have to substitute here as R3. By substituting this equation, we are going to get by separating the real term and imaginary term later here. See here. Z1, Z4 we have used as it is. Z1, Z4 equal to Z2, Z3. From this equation, we can write Z1 equal to R1 plus JXL1. JXL1 is nothing but omega L1. So I have written here J omega L1 here. J omega L1 here. Plus Z2 equal to this R2 plus this R2, small r2 plus J omega L2 here now. XL2 is nothing but omega L2. Okay. Z3 equal to R3, Z4 equal to R4. Substituting these all values in the equation number 1, we'll get here that is called R1 plus J omega L1 into R4 equal to R2 plus J omega L2 into R3 here. No? So R1 into R4, I will multiply this one, R1 into R4 plus J omega L1 into R4 equal to here now. R2 plus R2 into R3 here, no? R2 plus R2, that real term here, no? R3 plus J omega L2 into R3 here. So from this equation, what we have to do? Now, the real term and imaginary term we have to separate here. So is there any imaginary term? If J is there, then that is called imaginary. There is no J term, only resistance part is there. That is called real term here. So this one is real term, R1, R4. Here it is now imaginary term equal to this one is real term. Is there any J here? No, complex term is not there here. No. So R1, R4 equal to this R2 plus R2 into R3 we have to write here. R1, R4 equal to R2 plus R2 into R3. Substitute here now. Now what is the unknown resistance? R1 here now. So R1 equal to R2 plus R2 into R3 divided by R4 here now. We have got the formula. Now consider the imaginary terms here now. This is the imaginary term j omega L1 equal to j omega L2 into R3 here. J omega L1 R4 equal to j omega L2 R2. Here also j omega 2 is there, j omega is there, here also j omega is there. Both will get cancelled here now. Yes? Will cancel or not?
Yes, sir.
Both will get cancelled here now. This one and this one here. J omega L, j omega cancel here now. L1 equal to L1 R4 equal to L2 R3 here. So L1 equal to L2 R3 divided by R4 we can write. L1 equal to L2 R3 divided by this R4 I will send here. No. So this is the unknown inductance formula is there here. Unknown inductance का formula मिल गया आपको?
Yes, sir.
L1 equal to, can write L1 equal to R3 R4 into L2 here now, and R1 equal to R2 plus R2, that is small R2 into R3 divided by R4. We can note down this equation here now. This is inductance bridge only. This is only for the Maxwell inductance bridge only here. Okay. If it is Maxwell inductance and capacitance bridge, then what we have to do? We can do that one here. So what we will do in this practical, only Maxwell inductance bridge only will do. And in the next practical, this will take that one Maxwell inductance capacitance bridge. Actually, both will only one experiment only. But for your understanding up to here, you remember this formula. You remember this formula. So next Maxwell inductance capacitance bridge, we have used here, capacitance is used here. This theory and practical will do in the next practical. And this one already we have discussed this theory. We'll do the practical here now in the virtual lab. I will show you how we will get the answer of that one. You note down this formula. The formulas you note down. Based on that, you'll get that one calculated value and measured value. It should have to match over there. Okay. So I will stop sharing here. And I will open that what we have to open. Google Chrome I will have open. I will show that one. I have to check that. Is the screen is visible? Screen visible है क्या? Is it audible?
Yes, sir.
So what we have to open? We have to open vlab.co.in. That is virtual lab. It is going to open. Virtual lab. It is going to open. So this is the main page of the virtual lab. It will get open already. I have told you people about that one. So the Ministry of Education under the National Mission of Education through ICT content, it is added, and some broad areas of virtual lab they have described here now. But this, whatever the subject we are studying here now, it is designed by electronics labs. We are discussing about the measuring instruments here now. So this subject is there in electronics and communication subject. So you have to choose this broad area. Area of the subject is electronics and communications. You have to choose that one. In this one, so different subject will be get open. So this fading channels and all the things we are designed by IIT Kharagpur, COEP Pune, IIT Kanpur, like that. So in that one, where is the measurement lab? We have to identify here now by checking this one, analog signal networks and measurement lab is there here. You have to click on this. Click on measurement lab here now. Next, the introduction part it is going to open here now. First, the introduction part of this laboratory. All three subjects are there here now. All three subject: basic electrical, signals and networking, and measurement laboratory. They have explained about basic of that one. Our aim is next we have to open the experiments here now. So I will click on the list of experiment. I'll click on the list of experiment. It will opens all 3 subject experiments here now. In that one, we have to choose our particular subject here. That is measurement laboratory for UG students of electrical engineering, electronics and communication engineering, and instrumentation engineering here now. Here, where is the Maxwell bridge you have to identify here? Where is the Maxwell bridge you have to identify here? See here, self-inductance of quality factor coil by Hayes bridge is there. It is not there. So here, self-inductance by Maxwell bridge is there. And one more is there also. Measurement of capacitance by Wayne series bridge, self-inductance by Maxwell bridge here now. 2 bridges they have given. In these 2 bridges, what you have to do? One bridge is Maxwell inductance bridge, another one is Maxwell inductance and capacitance bridge here. So I will open in new tab, both I will open that one. Today we are going to discuss only about Maxwell inductance bridge. We are going to discuss. Today we are going to discuss only Maxwell inductance bridge. That is called, this is the Maxwell inductance bridge here now. So the first one, this is Maxwell inductance bridge here now. See here, measurement of self-inductance by Maxwell bridge here now. So the main objective of this experiment is to determine the self-inductance of an unknown coil here now. This is the unknown coil we are using here now. That is the, we have to identify the inductance of this coil here now. Okay, theory part already we have discussed here now. See here, R1 and L1 are the unknown we are going to consider here now. According to the formula of previously, whatever we have derived formula, based on that we have to measure this one here now. And R2, R3, R4, these are the variable. By varying these resistances and this inductance, we can make the bridge into balanced condition here now. Make the bridge into balanced condition. Whatever I told that one, Z1, Z4 equal to Z2, Z3 here now. This is the R1 plus J omega L1, that is Z1, R4 equal to Z4, Z2 equal to R2 plus J omega L2, and Z3 equal to R3 here now. By comparing the multiplying, rearranging the equations and separating the real term and imaginary term, we will get this L1 equal to R3 R divided by R4 into L2, R1 equal to R3 R4 R divided by R4, R2 plus R2 here now. These equations already we have derived just now. We have derived here. According to the virtual lab, what is the procedure we have to discuss here? How we have to do the experiment in the virtual laboratory. This is the circuit diagram is there. First, what we have to do? We have to apply the supply voltage from the signal generator with arbitrary frequency. That is, we are going to apply 3 volts. They have mentioned here. No. So 3 volts we can apply that one. Also set the unknown inductance value from the set inductor value here now. So this one, we can set the unknown inductor value here. We can unknown inductor, whatever the L1 value is there, can set that one over there. Okay. So next, then switch on the supply to get the multi-voltmeter deflection. Once the switch on the supply, then what will happen? This millivoltmeter is there here. This one, if it is showing some value, means the current is flowing here. No, we have to make this one as 0 by adjusting the other value. That is the next step here now. The next step is choose the values of L2, R2, R2, R3, and R4 from the inductance and resistance box. Where is the values to some particular values to achieve null here now? Null means whatever the detector is there here, null detector. To achieve this one as 0, we can vary this one, this capital R2, L2, small R2, R3, and R4 here. All these terminals are variable only. This is the resistance box, and these are the, this is inductance box here. So by varying this resistance and this one, we can bring the bridge into balanced condition. We can bring that one. So next, once the null is achieved, then observe the millipointer to achieve null here. No, we have to observe that it is null, it is 0 or not. We have to observe that one. So if null is achieved, switch to measure inductance value tab and click on to simulate here now. Once the null is achieved, then what we have to consider here now, we have to switch the measure inductive value tab. We have to click on and click on simulate, observe the calculated values of unknown inductance and its terminal resistance R1 of the inductance here now. Also observe the dissipation factor of unknown inductance, which is defined as omega L by R here now. Omega L1 by R1 also, by using this one also can calculate the dissipation factor we are going to calculate here now. This is the procedure here. So what is the operating environment? What is the requirement? Previously, that is a PC is required. We should have minimum 512 MB RAM and 1024 into 768, the high screen resolution, a mouse or other pointing device, the CD-ROM drive it should have. That is the minimum requirement of the to operate this virtual lab here. So shall we go for the simulator now? We'll go for the simulator. All of you have done it. This same subject you have studied in the diploma, but whatever you have not studied in the virtual lab, that is the main thing. So you are going to, some people's ENTC students are there and computer science students are also there here now. So see, whatever the theory I am explaining, once again in the third unit in deep, I am going to explain with phasor diagram. This is whatever I have explained, which is required to understand the practical. For that reason only I am explaining here. Okay. So I will click on to perform the experiment. I will click on this one. The new window will open with circuit diagram, some variation of codes, and whatever that values we can use here. See here. This is the circuit diagram we have used here now. Where we have to fix this one, I will fix here only. Okay. Is it visible?
Yes, sir.
Okay. See here. This is the circuit diagram. This is millivoltmeter value it is going to give here now. So R3 value, R2 value, this is L2 value we can vary here, and R2 value also we can vary here now, and R4 also we can vary here. So these one can set by using the inductor value, we can set that one here. This is a fixed one, we are going to call that one here. So in the left side, they have given the procedure here now. They have given the procedure. According to that procedure, we have to calculate here now. So what we have to do, we have to set the inductor value. So first what we have to, for air core, we have to set 45 millihenry. And for the iron core, we can set 450 millihenry here now. And we can set here now. Once we clicked on this button, it is going to set here now. The range of L2 equal to 10, what is that one? UH, Euro Henry to 111 millihenry. We can vary that one here now. Unihenry to that one here. Though R2, R3, that is in mega ohm also we can vary here now. This resistances we can measure in the mega ohm, but this all the resistances we can vary by using here now. The tab is there here. We can vary by using this one. Can increase, we can decrease, whatever we can do that one. So here, once before performing that one, we have to set button, we have to click. Then after that one, to measure that one, we have to click on the measure button here. So we have to simulate it here, means the current voltmeter reading, what is that one is, that is it is going to detect here now. And next, the now click on to simulate, click karne ke baad inductor value, how much is there, that inductor value it is going to display here, and resistance value it is going to display R1, and quality factor here. Now what is the requirement is there, based on that it is going to deflect here now. So you have to write in a table like that. You have to take one table that is called serial number you have to take down, that is, and R1, R2, small r2, R3, R4. R1 karene do, R1 you keep left, it is R2, capital R2, small r2, R3, R4, L2 you have to write. Next, L1 and L1, one side observed, one side calculated. R1, one side observed, one side calculated. Like that you have to write down over there in the observation table. So according to procedure, we'll start to simulate this one, this practical. We are going to start. First, what we have to do, we have to set the voltage here. I will set it into 4 volt. I will set here now. So 5 volts I will set that one. The frequency also I will set as 50 hertz only here now. So here we can choose that one, air core and inductor, iron core, we can choose that one here. I will choose the air core button, I will choose that one. So for the air core, it is 45 millihenry is there. So R1 equal to 40.2 volt is there here now. So this is determined value. We have set at this one here now. Okay. Next, what we have to do? Apply the supply voltage 3 volt from the signal generator with arbitrary frequency. You have added 3 volts. They have told I have applied 5 volts. Okay. Select the type of unknown inductor for air core or iron core. I have chosen as air core here now. From the set inductor value tab by clicking on the set button here. Now I will set here. Where is the set button? Here it is there. I will click on this one. I will click on this set button. It is setted now. The value is setted now. Next, what we have to do? We have to switch on the power supply to get the millivolt deflection. What is the value here now? This value. What is the value here?
0.
0 is there. After switching on, see here, you can check that one. The value is changed here. Yes.
Yes, sir.
The value is changed here now. From this one, this value, whatever it is changed, by varying this resistance R2, R3, R4, we can change that value here now. So I will check that one by increase or decrease here now. It is what 2, 3 tha, just by increasing R2, it is came to 1500 now. 1500 millivolt. Once again, I will increase here. It is decreasing now. Yes. You
Yes,
have to
sir.
make that one as 0 here now. So this R2 also I will increase that. It will be around 2 ohm I will set. If I will increase this one, means what will happen? It is increases. Okay. See here, it is by increasing this one also, it is decreasing here now. No. Particular value होने के बाद suddenly it is increasing. See over there. Somewhere here only. 104. 324. It is increased now again. I will increase this one. 102. Yes, sir. Plus. नीचे इस तरफ. So this one, see here, I can change the inductance value also. I will change here 20, 200. Okay. This one e to the power of -4 is 6 is there. I will take this one as -2. Okay, it is decreasing now here. -3. So -4 decreasing now. Instead of this 200, I can take 500. No, it is increased now again. 45, 50, 500, 100. 45. Next, I will increase this one. What happened? Someone has logged in. So little bit changes will be there. Here only we have to do. Instead of this one 0.9, I will give here now. Okay. 0.1. No. 8, 9, 355. 0.7. See, a small changes will be there here now. 34 it came. 2, no. 3, 4, 5, 6. For 6 it is increasing here now, decreasing. 40 okay. Again we can change 3.8. No. 1. No. See, this much variation we have to do for the 5 volts. समझ में आ रहा है भाई? 34 millivolt we have occurred. Then also we are not getting here. 105. I will do that one. Okay. 110, 27, 154, 160, 150, 5, 1, 145, 46, 6, 47, 48, 49. How much variation is there? A small variation it is occurring here. Yes or no? Someone is unmute. Mute kar rahe. Rule number 21. Jagdish, what is problem?
Sorry, sir.
Okay, 1 point. Is 10 means no. 1.01. Okay. 02. No. 001. This is 01 only. So now it is 1.743 millivolt is there. Just a minute. This is L1. 0.01. 2.9. No. This is 3 only. Leave as it is. 3 only here now. So little bit I changes I will do. 01. No. Directly 1. No. So instead of 13, 12.9. Okay. 12.8 it is decreasing now. No. 12.88. No. 12.8 only here now. 3 it came. 13.0001. No. 13 only it is coming. Yes, so much fluctuation is there here now. 0.01, 73, 02, 2 here now. 1.66, 5, 8, 9, 151 I will add here now. 52, 53, no, 52.5 is decreased now. 1, 2, 6, 1, no, 5, 8, 5, 6, okay, 5, 5. See, varying it is 4, 9, no, 5, 1, 2, 3, 4, 5, 3 here now. Little bit variation. 0.004 means what is the value here now? You can say that it is almost 0 only, na? Yes.
Yes, sir.
0, 1. We will take that one also. Will reduce. I will try. Just a minute. Still 6 minute time is there. See here, almost it is 0.441 millivolts is there. The null here I will change it. Just a minute. So much sensitive is there, that is sensitive detector. Why they have told me is that is the reason here now. 151, 1 is there, 2 I have taken this. 0.9. Okay, here only it is there. See here, it is coming down. 0.08 is there. Yes.
Yes, sir.
45. Okay, 0.08, that is almost it is achieved here. The null detector we have achieved this one. Can called that is 5.3. 2, 4. Okay, see here. It achieved 0 now. Complete 0 is there. Yes or no? So what you have to do, you take screenshot of this one. This is the R2 value, this is the L2 value, this is the small R2 value, and this is R4 value, this is R3 value. So the L1 is 45, R1 is, this is the setted value here. Now what we have to do, we have to, next procedure is null is achieved here. Now what we have to do, we have to measure inductor value here. Now we have to click on this and we have to do the simulation here. Now it is going to display the value here. I will do the simulation here. See here, the 0 is there. Inductor value, how much it is showing here now? L1 45. How much we have set it here? 45 set kiya tha pehla. So setted value we have got. The resistance value also 40.2 and the quality factor or dissipation factor we are going to call, that is called 0.35. Like this we have to do for the simulation here. Now we have to do in the virtual lab here. Now you can note down these values by using the formula you calculate here. Now you can calculate the values also here. Already you know the formula, R1 equal to R2 plus R2 into R3 divided by R4, and L1 equal to L2 R3 divided by R4 here. Now that formula, by using that formula here, R2 value is there. This is e to the power minus 4, that is called 10 to the power of minus 4, 151.5 into 10 to the power of minus 4, you have to do that one. See, in the practical it will take so much time to adjust this load here now to make this galvanometer 0. Small variation here now, by changing this one only it has changed here now. So point also it is varying. Suppose if I increase it this one more, then it will not come 0 here now. That is also tricks is there. Which point we have to vary, this one or this one here. Already this is unknown, means these two paths are same only. Maximum we have to adjust this path only here. By adjusting these two paths, we can get the value of the unknown inductance we have measured here. Yes. Rule number 21. How many times I have to tell you? Huh? Okay. So this is experiment number 6. That is measurement of self-inductance. Again, experiment number 6 is not complete. This is only Maxwell inductance bridge. In the next week, we will discuss about the Maxwell inductance and capacitance bridge we are going to discuss. After that, you can complete the write-up part. Okay. We'll stop here only and we will continue in the next practical. Any doubts you have? If you have any computer, laptops, or if you visit, want to visit to the college, you can come and you can practice this one in the laboratory, computer lab. Okay. Any doubts?
No, sir.
So we'll stop here only then. Attendance, na? Roll number 11, 17, 19, 25, 27, 29, 36, 37. These are the absent roll numbers. Okay. I will end here only. Continue in the next class.